August 3, 1944, RAF Manston, Kent, England. Staff Sergeant Mike Reeves stood in the maintenance hangar staring at the most beautiful aircraft he'd ever seen, and hated every line of it. The Focke-Wulf FW-190 sat under work lights like a predator at rest, its broad nose and compact fuselage radiating lethal efficiency. The fighter had been forced down 2 days earlier after taking hits during a strafing run over Normandy. The pilot had dead-sticked it into a field near Dover, walked away from the crash, and was now in a POW camp. The aircraft, remarkably intact, had been trucked to Manston for technical analysis. Reeves was a mechanic, had been since before the war, working on Fords and Chevys in a garage outside Detroit. When Pearl Harbor happened, he'd enlisted in the Army Air Forces because he figured engines were engines, whether they powered cars or fighters. Turned out he was right. 3 years later, he was an expert on Pratt & Whitney radials, Rolls-Royce Merlins, and increasingly captured German aircraft that intelligence wanted disassembled, analyzed, and understood. The FW-190 was his 5th German fighter. He'd worked on 2 Me-109s, a Ju-88 bomber and a Me-110 night fighter. Each time he'd been impressed by German engineering, the precision manufacturing, the efficient design, the attention to detail that made their aircraft formidable opponents. American planes were tough, reliable, built for mass production. German planes were refined, optimized, built like expensive watches. This FW-190 was no exception. The BMW 801 radial engine was a masterpiece, 14 cylinders, fuel injection, supercharging 1,700 horsepower. The airframe was compact and rugged. The control surfaces were beautifully balanced. Even damaged, the aircraft exuded quality. Captain Thomas Brennan, the intelligence officer overseeing the analysis, approached carrying a clipboard. "Sergeant, headquarters wants a complete teardown. Engine, hydraulics, control systems, everything. They want to know if we can identify any weaknesses we can exploit." "Exploit how, sir?" "If we understand how their aircraft work, maybe we can figure out how to make them not work." Brennan tapped his clipboard. "The Luftwaffe has been hurting lately, losing pilots, losing fuel, losing manufacturing capacity. But they're still putting up resistance. If we could find a way to degrade their operational capability beyond just shooting them down, it would shorten the war." Reeves looked at the FW-190 skeptically. "Sir, these planes are built solid. I don't see obvious weaknesses we could exploit remotely. We'd have to sabotage them directly, and we don't have access to their airfields." "Not their airfields, their supply chain." Brennan opened a folder and pulled out photographs, images of bombed German factories, rail yards, and logistics depots. "We've been hitting their production facilities for months. Parts are getting scarce. They're cannibalizing damaged aircraft to keep others flying, which means they're using salvaged components, bolts, fittings, seals, from multiple sources. And if we understand which components are critical and prone to failure, we could target those specifically. Or better yet, find ways to introduce failures that look like normal wear rather than sabotage." Reeves walked around the FW-190, studying its construction. "You're talking about psychological warfare through mechanical failure. Make them distrust their own aircraft." "Exactly. The Germans are already stretched thin. If we can make them ground aircraft for maintenance investigations, burn through spare parts troubleshooting phantom problems, or lose confidence in component reliability, it degrades combat effectiveness without firing a shot." It was clever, ruthless but clever. Reeves had spent 3 years keeping Allied aircraft flying. Now he was being asked to figure out how to make enemy aircraft stop flying, not through direct combat but through exploiting mechanical vulnerabilities. Over the next week, Reeves and 2 other mechanics disassembled the FW-190 completely. They cataloged every component, measured every tolerance, documented every assembly procedure. What they found was both impressive and revealing. German engineering was exceptional, but it was also rigid. Components were precision manufactured to exact specifications. Tolerances were tight. Everything fit together perfectly, but only if every part met those precise specifications. There was minimal margin for error, minimal accommodation for worn components or field repairs. American aircraft, by contrast, were designed for flexibility. Parts had looser tolerances. Mechanics could file, shim, or improvise repairs. A damaged P-51 could be patched together with salvaged parts and keep flying. A damaged FW-190 required exact replacement components, or it didn't fly at all. That rigidity was a vulnerability. On August 10, Reeves found something interesting. The BMW 801 engine used a complex system of accessory drives, gears that powered the fuel pump, oil pump, magnetos, and supercharger. All of these were mounted on the engine's rear accessory section, driven by a central drive shaft connected to the crankshaft through a series of gears and couplings. One of those couplings was secured by a bolt, a simple, unremarkable fastener that kept the drive shaft aligned with the drive gear. It was a critical component but easy to overlook. If that bolt failed, the drive shaft would slip out of alignment. The accessory drives would stop functioning. The engine would lose fuel pressure, oil pressure, and ignition. It would quit within seconds. And here was the interesting part. The bolt was a standard metric size, M8x125, 30 length, grade 8.8 hardness. Nothing special. Something that could be sourced from any industrial supplier. Something that could be manufactured easily. Something that, if replaced with a substandard version, would fail under stress without obvious signs of sabotage. Reeves brought his findings to Captain Brennan. "Sir, I think I found something. The accessory drive coupling bolt on the BMW 801. It's critical, it's standard specification, and if it fails, the engine quits immediately." Brennan studied the disassembled components Reeves had laid out on a workbench. How hard would it be to make this bolt fail? Replace it with a bolt that looks identical but has lower material strength. It'll hold during ground testing and initial flight, but under sustained combat power, high RPM, high temperature vibration, it'll fatigue and break. And when it breaks, engine failure. Pilot has to dead stick it back to base if he's lucky, bail out if he's not. Either way, that aircraft is out of action. Brennan was quiet for a long moment. "Can you make a bolt like that? One that looks right but fails predictably?" Reeves thought about it. "Yes, sir. I'd need softer steel machined to the right dimensions. Looks identical, threads properly. Torques to specification. But it's grade 5.8 instead of 8.8. Under combat stress, it fails." "How many could you make?" "Dozens, hundreds if we had machine shop time and raw material. And if those bolts got into the German supply chain, then every time a mechanic replaced an accessory drive coupling bolt, which happens during routine maintenance after engine repairs or when salvaging parts, there'd be a chance they'd install a faulty one. The engine would work fine initially, then fail during flight. The Germans would investigate, find a broken bolt, assume it was a manufacturing defect or material failure and order more bolts, which might also be faulty." Brennan smiled slowly. "That's diabolical." "That's mechanical warfare, sir." Over the next 3 days, Reeves fabricated 20 prototype bolts using mild steel instead of hardened alloy. They looked identical to the original BMW bolts, same head markings, same thread pitch, same length. But they were softer, weaker, designed to fail under sustained stress. He tested one by installing it in the captured FW-190's engine, running the engine at combat power for 30 minutes, then inspecting the bolt. It showed stress fractures. After 45 minutes, it would have failed completely. On August 15, Reeves presented his work to a joint meeting of intelligence officers, operations planners, and OSS personnel. He explained the vulnerability, demonstrated the faulty bolt's failure characteristics, and proposed a plan: manufacture thousands of counterfeit bolts and introduce them into the German supply chain through resistance networks, captured logistics depots, or sabotage operations. The response was immediate interest and immediate skepticism. "This is sabotage," one intelligence officer said. "It violates Geneva Conventions regarding treatment of enemy equipment." "It's mechanical exploitation of a design vulnerability," Brennan countered. "We're not poisoning pilots or booby-trapping cockpits. We're introducing substandard parts into a supply system that's already struggling with quality control. And if it works, then we ground a significant portion of the Luftwaffe's fighter strength without firing a shot. We force them to waste time troubleshooting failures, burn through spare parts, and lose operational tempo." The meeting continued for 2 hours. Legal concerns were raised and dismissed. Operational feasibility was debated. Production capacity was assessed. And at the end, authorization was granted for a limited trial: produce 500 counterfeit bolts, introduce them into captured German supply depots in France, and monitor results. Reeves spent the next month overseeing production. 500 bolts, each one manufactured to look exactly like legitimate BMW parts, each one engineered to fail under combat stress. They were packaged in authentic-looking containers, labeled with German part numbers, and delivered to OSS operatives in France, who would plant them in captured German logistics depots that the Wehrmacht was still trying to access through black market channels. Nobody knew if it would work, but if it did, a mechanic's junk bolt, dismissed as scrap metal by everyone who didn't understand its purpose, was about to become one of the war's strangest weapons. September 12, 1944, Metz, France. The German supply depot at Metz had been abandoned in August when Allied forces approached, then hastily reoccupied in September when the German army established a defensive line along the Moselle River. The depot contained aircraft parts, ammunition, fuel drums, and spare equipment salvaged from retreating Wehrmacht units. It was a chaotic collection of materiel, some new, some damaged, some salvaged from destroyed aircraft and vehicles. Luftwaffe mechanics scavenged what they could. The 3rd Jagdgeschwader Fighter Wing 3, operating from nearby airfields, desperately needed parts. BMW 801 engines were wearing out. Components were failing. Replacement parts weren't arriving from Germany because Allied bombing had crippled rail networks and destroyed factories. So mechanics improvised. They pulled parts from wrecked aircraft. They bartered with other units. They sent requisition teams to abandoned depots like Metz, hopping to find usable components. On September 14, a requisition team from JG3 arrived at Metz. They found limited supplies but managed to acquire 30 accessory drive coupling bolts for BMW 801 engines, exactly the type they needed for routine maintenance and repairs. The bolts looked legitimate: proper markings, correct dimensions, standard packaging. The mechanics didn't question their origin. They loaded them onto a truck and returned to their base at Freskady Airfield, 15 kilometers east of Metz. Over the next week, those bolts were installed in 12 different FW-190 fighters during routine maintenance. The installations were textbook perfect. Mechanics torqued each bolt to specification, tested engine function, and signed off on the work. The aircraft returned to operational status. On September 23, at 8:47 hours, Lieutenant Hans Weber took off from Freskady in FW-190A8, number 470,254, for a bomber interception mission. The engine performed flawlessly during takeoff and climb. Weber joined his formation at 22,000 feet and proceeded toward the reported position of American B-17s heading toward Frankfurt. At 9:12 hours during combat maneuvering at high power settings, Weber's engine quit without warning. No sputtering, no warning signs, just sudden, total silence. The BMW 801 had been running at 2,700 RPM under combat load when the accessory drive coupling bolt fractured. The drive shaft slipped out of alignment. Fuel pressure dropped to zero. The ignition system failed. The engine seized. Weber had altitude and managed to glide toward friendly territory. He dead-sticked the FW-190 into a field near Saarbrücken, damaging the landing gear but walking away uninjured. When mechanics examined the aircraft, they found the broken bolt. It looked like a material failure, fatigue fracture under stress. Nothing suspicious. Just a part that had failed, probably due to poor quality control at whatever factory had manufactured it. 2 days later, another FW-190 from the same unit experienced identical engine failure. Then another. Then 2 more within a week. By early October, JG3 had lost 8 aircraft to what appeared to be accessory drive coupling bolt failures. The aircraft themselves were salvageable. Engine replacements could get them flying again, but the pattern was alarming. The wing's chief mechanic, Hauptfeldwebel Otto Kraus, ordered an investigation. He examined every broken bolt, compared them to specifications, and found nothing obviously wrong. They looked like legitimate BMW parts, but they kept failing. Kraus ordered replacement of accessory drive coupling bolts on every aircraft in the wing, whether they showed signs of wear or not. 53 aircraft grounded for preventive maintenance. 96 man-hours per aircraft to access the engine's rear accessory section, remove the old bolt, install a new one, and test engine function. The wing was effectively grounded for 10 days, while the work was completed. Meanwhile, the faulty bolts had spread beyond JG3. The Metz depot had supplied parts to 3 other fighter wings and 2 bomber units. Between late September and mid-October, the Luftwaffe experienced 27 unexplained engine failures across multiple units, all traced to failed accessory drive coupling bolts. German logistics officers began investigating. They tracked part numbers, checked manufacturing records, contacted factories. They discovered that some bolts had come from authorized suppliers, but others had originated from salvaged stocks or captured depots, sources that couldn't be verified. A directive was issued on October 18. All accessory drive coupling bolts from non-verified sources were to be removed and destroyed. Only parts directly from BMW or certified subcontractors would be used. The directive was logical. It was also impossible to implement. The Luftwaffe was desperately short of parts. Refusing to use salvaged components meant grounding even more aircraft. Mechanics had to choose between flying with potentially faulty parts or not flying at all. Most chose to fly, and the failures continued. By November 1944, the faulty bolt problem had evolved from a localized issue to a systemic crisis. What had started as 27 engine failures had grown to over 60 as counterfeit bolts continued circulating through the German supply network. The Luftwaffe's response was rational but self-destructive. Unable to verify which bolts were legitimate and which were faulty, they began replacing all accessory drive coupling bolts regardless of source. This required grounding aircraft for time-consuming maintenance, burning through the limited supply of verified parts, and diverting mechanics from other critical work. Wing commanders protested. Operational tempo was already suffering from fuel shortages and pilot attrition. Now they were losing additional sorties to maintenance investigations of a single component, but without confidence in part reliability, they had no choice. The problem compounded as rumors spread among pilots. Engine failures during combat were terrifying. Loss of power at low altitude meant almost certain death. Pilots began reporting hesitation to push engines to combat power, preferring to conserve power and maintain margins for emergency situations. This reduced combat effectiveness even in aircraft that hadn't experienced failures. Meanwhile, at RAF Manston, Staff Sergeant Mike Reeves was tracking results through intelligence reports. The OSS had successfully introduced approximately 400 of the 500 counterfeit bolts into German logistics networks. The remaining 100 had been intercepted or lost during distribution operations. Those 400 bolts had caused documented failures in at least 60 aircraft, a 15% failure rate that matched Reeves's predictions. But the indirect effects were far more significant. German maintenance directives showed that hundreds of additional aircraft had been grounded for precautionary inspections. Thousands of man-hours had been spent investigating the problem. Supply chains had been disrupted as factories rushed to produce verified replacement parts. Captain Brennan reviewed the intelligence summaries with satisfaction. "Your junk bolt is causing more operational disruption than we anticipated. The Germans are tearing apart their own maintenance system, trying to solve a problem they don't understand is deliberate sabotage." "Do they suspect sabotage?" Reeves asked. "Intelligence intercepts suggest they're debating it. Some officers think it's poor manufacturing quality from wartime production pressures. Others suspect sabotage but can't prove it because the bolts look authentic. A few are convinced it's statistical bad luck, a batch of defective parts that slipped through quality control." "What do they actually think happened?" "They don't know. That's the beauty of this. We've introduced enough uncertainty that they're questioning everything. Are the parts legitimate or fake? Are their supply chains compromised? Can they trust salvaged components? Every question burns time and resources." Reeves felt an odd mixture of pride and unease. He designed a mechanical trap that was elegant in its simplicity, a component that looked right, installed correctly, and failed predictably. But watching the Germans struggle with the consequences felt different from maintaining Allied aircraft. This wasn't combat. It was systematic degradation of an enemy's operational capability through exploitation of their own logistics. It was also working. Intelligence estimated that the counterfeit bolt operation had reduced Luftwaffe fighter sorties by approximately 12% in the affected wings, a reduction comparable to what might be achieved by destroying aircraft in combat, but accomplished through mechanical sabotage rather than aerial engagement. In November, authorization came through for expanded production. 1,000 additional bolts, to be introduced through resistance networks in occupied territories and captured supply depots as Allied forces advanced into Germany. Reeves supervised production of the second batch. The process was refined, better manufacturing tolerances to make the counterfeit bolts even harder to distinguish from legitimate parts, better packaging to match German standards, better distribution planning to spread them across multiple logistics networks. But something had changed. What had started as an interesting technical problem, how to make an enemy aircraft fail, had become industrial-scale sabotage. Reeves was no longer just a mechanic fixing Allied planes. He was a weapons designer whose weapons happened to be counterfeit bolts that looked like junk, but functioned as tools of systematic disruption. On November 28, he received an unexpected visitor, Colonel James Hartford, a senior logistics officer from 8th Air Force Headquarters. Hartford got straight to the point. "Sergeant, your bolt operation has attracted attention at the highest levels. General Eisenhower's staff wants to expand the concept. Not just bolts, other components, hydraulic fittings, electrical connectors, fuel line seals, anything we can counterfeit and introduce into German supply chains." "Sir, that's a massive undertaking. Each component requires different engineering analysis, different manufacturing processes, different failure characteristics." "I understand. That's why you're being promoted to technical sergeant and assigned to a new unit, the Mechanical Countermeasures Group. Your job will be to identify vulnerable components in German equipment and develop counterfeit versions that fail predictably. Reeves stared at him. You want me to build an entire sabotage program around mechanical failures? I want you to turn German logistics into a weapon against itself. Every fake part we introduce forces them to waste time, burn resources, and lose confidence in their own equipment. It's force multiplication through systematic disruption. What if they figure out it's deliberate? Then they have to inspect everything, which is even more disruptive than the failures themselves. Either way, we win. Hartford handed him orders. You'll have a team of 10 mechanics, access to machine shops, and priority for materials. Your first assignment: analyze captured German vehicles, trucks, tanks, armored cars, and identify components we can counterfeit to degrade their ground logistics the same way you degraded their air operations. Reeves took the orders, feeling the weight of what was being asked. He'd started by disassembling one FW-190 to understand its vulnerabilities. Now, he was being asked to wage mechanical warfare across the entire spectrum of German military equipment. It was brilliant, it was ruthless, and it would work. Over the next 4 months, Reeves and his team would introduce thousands of counterfeit components into German supply networks: faulty magnetos, weak fuel line fittings, substandard hydraulic seals, each one engineered to look authentic, install correctly, and fail under stress. The Germans never figured out the full scope of what was happening. They attributed failures to poor wartime manufacturing, sabotaged factories, or supply chain corruption. They implemented inspection protocols, tightened quality control, and burned enormous resources trying to solve a problem they didn't realize was being deliberately created by an American mechanic with a box of junk bolts and an understanding of how machines break. December 14, 1944, Luftwaffe Technical Command, Berlin. Oberst Heinrich Brauer, chief of Luftwaffe Logistics and Supply, stood before a conference table covered with failed components: bolts, fuel fittings, hydraulic seals, magnetos, all collected from aircraft that had experienced unexplained failures over the past 3 months. 32 officers sat around the table: mechanics, engineers, logistics specialists, and intelligence officers, assembled to solve what had become the Luftwaffe's most perplexing operational crisis. Gentlemen, Brauer began, since September, we have documented 127 engine failures, 43 hydraulic system failures, and 18 electrical system failures across fighter and bomber wings. All failures traced to component defects. All components appeared legitimate during inspection and installation. All failed under operational stress. He picked up one of the bolts. This is an accessory drive coupling bolt from a BMW 801 engine. According to specifications, it should withstand stresses of 800 megapascals. Laboratory analysis shows this bolt failed at 520 megapascals, 35% below specification. Yet it bears correct factory markings and came from what appeared to be a legitimate supply depot. An engineer from BMW spoke up. Oberst, we've analyzed 12 of these failed bolts. 4 show metallurgical composition consistent with our manufacturing standards. 8 do not. Those 8 appear to be made from inferior steel alloy, possibly salvaged material or substandard wartime production. Could this be manufacturing defects at approved factories? Possible but unlikely. Our quality control would have caught such severe deviations. More probable is that these parts came from unauthorized sources, black market suppliers, salvaged stocks, or what? The engineer hesitated. Or deliberate sabotage, sir. The room went quiet. Sabotage implied enemy infiltration of supply chains, which meant the problem went far beyond simple manufacturing defects. An intelligence officer named Major Klaus Werner cleared his throat. We've investigated 3 scenarios. First, Wartime production pressures have degraded quality control at legitimate factories. Second, black market suppliers are producing counterfeit parts. Third, enemy sabotage through resistance networks or captured depots. Which scenario is most likely? Brower asked. All three are possible, but the distribution pattern suggests scenario 3. Failed components have appeared across multiple wings, multiple regions, multiple supply chains. The only common factor is that all originated from salvaged stocks or captured depots that were temporarily under enemy control. Brower set down the bolt. You're telling me the Americans have infiltrated our logistics network and are introducing fake parts designed to fail. We're saying it's a possibility that explains the data better than coincidence or poor manufacturing. If that's true, how extensive is the infiltration? Unknown. We've identified approximately 200 confirmed counterfeit components, but there could be thousands more in supply depots waiting to be installed. The implications were staggering. If enemy sabotage was real and widespread, the Luftwaffe couldn't trust any salvaged parts. That meant grounding huge portions of the fleet for component replacement, massively increasing maintenance workload, and potentially losing months of operational capability. But if they didn't act and the failures continued, they'd lose aircraft and pilots during combat, an outcome even worse than temporary grounding. Brower made his decision. Issue directive immediately. All aircraft will undergo complete component inspection. Every bolt, fitting, seal, and connector from non-verified sources will be removed and destroyed. Only parts directly from approved factories with verifiable chain of custody will be installed. Sir, that will ground nearly 40% of operational aircraft for weeks. Better grounded temporarily than falling from the sky permanently. Brower looked around the table. This war is lost, gentlemen. We all know it. But our job is to delay the inevitable as long as possible. If the enemy has found a way to degrade our operations through logistics sabotage, we must neutralize it, even if the cost is significant. The directive was issued on December 16, 1944. Across the Luftwaffe, aircraft were pulled from combat operations and subjected to exhaustive component inspections. Mechanics worked 18-hour shifts removing and examining every replaceable part, comparing them against factory specifications, destroying anything that couldn't be verified. The effort consumed over 200,000 man-hours. Operational sorties dropped by 35%. Fighter coverage over Germany weakened significantly during a period when Allied bomber raids were intensifying. And in England, Staff Sergeant Mike Reeves received intelligence reports documenting the German response. His junk bolt, combined with dozens of other counterfeit components his team had introduced, had forced the Luftwaffe into a massive self-imposed maintenance stand-down at a critical moment in the war. It wasn't victory through combat. It was victory through systematic exploitation of an enemy's trust in their own supply system, and it was working better than anyone had predicted. By January 1945, Reeves's Mechanical Countermeasures Group had expanded to 43 personnel, machinists, metallurgists, engineers, and intelligence specialists. They operated from a secure facility at RAF Bovingdon, manufacturing counterfeit German components and coordinating distribution through OSS networks. The operation had grown beyond aircraft parts. Reeves's team now produced fake components for German tanks, trucks, artillery, and even small arms. Each counterfeit was engineered to the same standard: look authentic, install correctly, fail predictably under stress. Panzer transmission gears made from sub-specification steel, truck differential bearings with inadequate lubrication, artillery breech blocks with weakened locking mechanisms. Each failure type was carefully designed to occur during operation rather than inspection, maximizing disruption while minimizing detection. The psychological impact was as important as the mechanical effect. German mechanics were losing confidence in their own repairs. Soldiers questioned whether their equipment would function reliably. Commanders hesitated to commit forces if they suspected their vehicles might break down mid-operation. Reeves coordinated with intelligence officers who tracked the operational impact. January reports showed Luftwaffe fighter sorties down 28% compared to September. Panzer operational readiness down 17% in Western Front divisions. Wehrmacht vehicle breakdowns up 34% during winter operations. German maintenance workload increased 45% for component inspections. The numbers represented thousands of hours of enemy effort, wasted troubleshooting problems that looked like normal mechanical failures, but were actually deliberate sabotage. But the operation also created ethical complications. Reeves was essentially weaponizing mechanical failure, making equipment lethal not through explosive force, but through reliability degradation at critical moments. In February, an intelligence report documented a Panther tank that had suffered transmission failure during combat near Remagen. The tank had been immobilized, then destroyed by American artillery. The crew had survived but been captured. Post-battle analysis suggested the transmission failure had been caused by a counterfeit gear Reeves's team had manufactured. Reading that report, Reeves felt conflicted. The tank crew hadn't been killed by the fake gear. They'd been captured because their vehicle broke down at the wrong moment. But if conditions had been different, that mechanical failure could have been fatal. He raised the concern with Colonel Hartford during a briefing. "Sir, we're causing equipment failures that put enemy personnel at risk during combat. That's different from shooting at them directly." Hartford didn't hesitate. "Sergeant, everything we do puts enemy personnel at risk. When we bomb their factories, we're trying to prevent them from manufacturing equipment. When we strafe their airfields, we're destroying aircraft before they can fly. When we introduce faulty parts, we're degrading their operational capability. The goal is identical: reduce their ability to wage war. The method is just more subtle. But there's a difference between destroying something and making it fail unpredictably." Is there? Either way, the equipment stops working and enemy forces become less effective. I understand your discomfort, but this operation is shortening the war by forcing the Germans to waste resources they don't have. Reeves knew Hartford was right tactically, but mechanically sabotaging equipment felt different from combat because it exploited trust. German mechanics installed parts believing they were legitimate. Soldiers operated equipment believing it was reliable. The counterfeit components betrayed that trust through invisible flaws designed to manifest at the worst possible moments. It was effective, but it was also fundamentally deceptive in ways that direct combat wasn't. Despite his reservations, Reeves continued the work. The war was ending. Allied forces were advancing into Germany. Every week of delayed German resistance meant more Allied casualties. If counterfeit components could degrade enemy effectiveness and save Allied lives, the ethical complications seemed worth accepting. By March 1945, the Mechanical Countermeasures Group had produced over 15,000 counterfeit components. Distribution networks had placed them throughout German-held territory, from logistics depots to repair facilities to frontline maintenance units. The cumulative effect was impossible to measure precisely, but intelligence estimates suggested the operation had reduced German operational capability by 8–12% across affected units, equivalent to destroying hundreds of vehicles and aircraft through conventional combat. As Allied forces captured German territory, they occasionally found stockpiles of counterfeit parts that hadn't been installed yet. These were quietly removed and destroyed to prevent them from being used by liberated Allied forces or accidentally entering post-war reconstruction efforts. The war ended in May 1945. Germany surrendered. The Mechanical Countermeasures Group was disbanded. Personnel were reassigned or discharged. The counterfeit components already in German supply networks were simply left there. Thousands of fake bolts, gears, and seals scattered across occupied Europe, invisible reminders of a sabotage campaign that had exploited trust and mechanical precision to wage invisible warfare. Reeves returned to the United States in June 1945, was discharged in July, and went back to Detroit. He returned to being a mechanic, but not the same mechanic who had enlisted in 1941. He'd spent 2 years building things and 2 years figuring out how to make enemy things break. The latter had been more psychologically complex than he'd expected. November 1945, Washington, D.C. In a classified briefing room at the Pentagon, 3 generals and 2 civilian intelligence directors reviewed the final report of the Mechanical Countermeasures Group. The document detailed operations, component types produced, distribution methods, and estimated operational impact. It also contained recommendations for post-war handling of the program's history. Colonel Hartford, now promoted to brigadier general, presented the key points. The countermate component operation was tactically successful. We estimate it reduced German operational capability by approximately 10% across affected units, equivalent to destroying thousands of vehicles and aircraft through conventional means. Total production cost, $340,000. Comparable destruction through bombing would have cost tens of millions and significant aircrew losses. Why classify this? One general asked. Seems like a success story worth publicizing. Hartford hesitated. Several reasons, sir. First, the operation violated conventional warfare norms by exploiting supply chain trust. Publicizing it could encourage similar tactics against our own logistics networks in future conflicts. Second, some components were introduced through resistance networks that engaged in questionable methods: theft, infiltration, black market operations. Third, the operation's success depended on the enemy not recognizing it was systematic sabotage. If future enemies know this tactic exists, they'll implement countermeasures. You're saying we should bury this to protect the technique for future use, and to avoid setting precedent that other nations might cite to justify sabotage of our equipment. A CIA director spoke up. There's another consideration. If word gets out that we deliberately introduced faulty components that may have caused deaths, even enemy deaths, it creates legal and diplomatic complications. Better to classify everything and keep the operation invisible. After 2 hours of discussion, the decision was made. The Mechanical Countermeasures Group's activities would be classified secret, with specific technical details classified top secret. Official histories would not mention the operation. Personnel involved would be instructed not to discuss their work publicly. The Junk Bolt Sabotage Campaign, one of the war's most cost-effective operations, would effectively disappear from official records. Mike Reeves learned about the classification when he received a letter from the War Department in December 1945. The letter thanked him for his service and informed him that certain aspects of his wartime work remained classified. He was instructed not to discuss the Mechanical Countermeasures Group, counterfeit component production, or related sabotage operations with anyone lacking appropriate security clearances. He filed the letter and never mentioned the work again. When people asked what he'd done during the war, he said he'd been an aircraft mechanic. When they pressed for details, he mentioned working on P-51s and B-17s. He never mentioned the FW-190 he'd disassembled, the counterfeit bolts he'd designed, or the systematic sabotage campaign he'd orchestrated. The work remained classified for decades. Official histories of World War II made no mention of mechanical sabotage operations. Books about logistics warfare focused on bombing campaigns and submarine blockades, not counterfeit components. The story of how one mechanic's junk bolt had grounded aircraft and degraded an entire enemy logistics network simply didn't exist in public records. Reeves lived quietly. He opened an auto repair shop in Detroit, married in 1948, raised 3 children, and worked as a mechanic for 40 years. He fixed Chevrolets and Fords with the same attention to detail he'd once applied to FW-190s and counterfeit bolts. His customers knew him as reliable, thorough, and surprisingly knowledgeable about German engineering. He died in 1989 at age 72. His obituary in the Detroit Free Press mentioned his wartime service as an Army Air Forces mechanic and his post-war career. It made no mention of sabotage, counterfeit components, or the Mechanical Countermeasures Group. His family cleaned out his workshop and found boxes of technical manuals, old photographs, and a Purple Heart he'd never mentioned earning. They also found a folder containing declassified documents from 1978, partial release of Mechanical Countermeasures Group records that acknowledged the program existed but provided minimal operational details. His son, Robert, read through the documents without fully understanding their significance. He donated them to the National Archives in 1992, where they were cataloged and effectively buried in boxes that few researchers would ever search through. The junk bolt had worked, the campaign had succeeded, the innovator had been forgotten. And for 50 years, that's where the story remained, classified, buried, and invisible. In 2003, a military historian named Dr. James Patterson was researching World War II logistics operations when he encountered a puzzling reference in declassified OSS documents. A footnote mentioned mechanical countermeasures operations, coordinated with resistance networks in France, but provided no details about what those operations entailed. Patterson requested additional documents through Freedom of Information Act channels. After 18 months and multiple appeals, he received heavily redacted files that confirmed the Mechanical Countermeasures Group had existed, but revealed little about its activities. One document, however, contained a name, Technical Sergeant Michael Reeves, listed as Primary Technical Advisor, Component Fabrication. Patterson tracked down Reeves's service record, discovered he died in 1989, and contacted his surviving family. Robert Reeves sent Patterson the documents his father had saved, including technical drawings of counterfeit bolts, production logs, and a handwritten journal documenting the FW-190 analysis. Those documents revealed the full story for the first time. Patterson spent 3 years researching, cross-referencing German records with Allied intelligence reports, interviewing surviving Mechanical Countermeasures Group personnel, and reconstructing the sabotage campaign's scope and impact. His findings were published in 2007 as a chapter in Shadow Warfare, Unconventional Operations in WWII Europe. The chapter, titled The Mechanics' War, Sabotage Through Supply Chain Exploitation, documented everything: the captured FW-190, the junk bolt design, the counterfeit component production, the distribution networks, and the operational impact. Patterson's research revealed that the campaign had been more extensive than even classified documents suggested. Over 18,000 counterfeit components had been produced and distributed. The estimated reduction in German operational capability was 10–15% across affected units, comparable to destroying thousands of vehicles through conventional bombing, but achieved at a tiny fraction of the cost. The chapter also documented the ethical debates within the program, including Reeves's concerns about exploiting mechanical trust and the decision to classify the operation to prevent similar tactics being used against Allied equipment. Patterson's book sold 6,400 copies, mostly to academic libraries and military historians. It was reviewed in 2 scholarly journals and mentioned in 1 military history magazine. It did not become a bestseller. It did not revise mainstream understanding of World War II logistics. But it preserved a story that had been deliberately hidden for 6 decades. Robert Reeves read the chapter and finally understood what his father had done. Mike Reeves hadn't just been a mechanic maintaining Allied aircraft. He'd been the architect of a sabotage campaign that had degraded enemy operations through systematic exploitation of their supply chains. In 2010, Robert contacted the National WWII Museum in New Orleans and offered to donate his father's documents. The museum accepted, creating a small archive of mechanical countermeasures group materials that researchers could access. In 2015, the museum opened an exhibit on unconventional warfare that included a display about the counterfeit bolt operation. The exhibit showed technical drawings, photographs of Mike Reeves, and examples of the types of components that had been counterfeited. The exhibit text explained, while Allied bombers targeted German factories from above, American mechanics targeted German logistics from within. By introducing counterfeit components that appeared legitimate but failed under stress, they forced the enemy to waste resources troubleshooting phantom problems and lose confidence in their own equipment. It was accurate. It was honest about the operation's nature, and it gave Mike Reeves credit for innovation that had remained invisible for 70 years. Robert attended the exhibit opening with his own children, Mike Reeves's grandchildren, and showed them the display about their grandfather's wartime work. "He never told us," Robert said. 50 years, and he never once mentioned that he designed weapons disguised as junk bolts. "Maybe he didn't think of them as weapons," his daughter replied. "Maybe he just thought of them as mechanical problems he'd figured out how to create." But they were weapons. They degraded enemy capability as effectively as bombs, just more subtly. And now, finally, people know. The recognition had taken 71 years, but it had arrived. By 2020, the counterfeit bolt operation had become a case study in asymmetric warfare and logistics sabotage. Military academies taught it as an example of cost-effective force multiplication. Intelligence courses analyzed it as a model for supply chain exploitation. Engineering programs studied it as an example of how mechanical design could be weaponized. The junk bolt itself, a simple M8X125 fastener that looked legitimate but failed predictably, had become symbolic of a larger principle, that trust in equipment reliability could be exploited as a vulnerability, and that systematic degradation could be as effective as direct destruction. Dr. Sarah Chen, a professor of military history at the Naval Postgraduate School, published a comprehensive analysis in 2018 titled "The Bolt That Grounded a Wing: Mechanical Sabotage in WWII." The paper examined the operation from technical, ethical, and strategic perspectives. Chen's research revealed several important insights. First, the counterfeit bolt campaign had been more effective than direct combat in certain metrics. Each fake component cost approximately $2 to produce, but caused an estimated $15,000 in enemy maintenance costs and operational disruption. The return on investment was extraordinarily high. Second, the operation's success depended on the enemy's assumption that their supply chains were secure. Once the Germans suspected sabotage, they implemented inspection protocols that reduced, but didn't eliminate, the operation's effectiveness. The lesson: supply chain exploitation works best when the target doesn't realize it's being targeted. Third, the ethical implications remained complex. Unlike conventional weapons that killed through direct force, counterfeit components killed through creating situations where equipment failed at critical moments. This indirectness made the operation legally and morally ambiguous in ways that straightforward combat wasn't. Chen's paper sparked debate in military ethics courses. Some argued that supply chain sabotage was a legitimate tactic no different from destroying factories or interdicting logistics. Others contended that exploiting trust in equipment reliability crossed ethical lines, because it made machines into unpredictable threats against their own operators. In 2022, a documentary filmmaker named Marcus Hayes produced The Invisible War, WWII's secret sabotage campaign. The film told Mike Reeves's story through interviews with historians, archival footage, and recreations of the counterfeit bolt fabrication process. The documentary was 48 minutes long, premiered at a military history festival in Virginia, and was later broadcast on the Military History Channel. Approximately 180,000 people watched it in the first year. For the first time, a general audience learned about the mechanic who had looked at a captured FW-190, identified a vulnerable component, and designed a weapon that looked like junk but functioned as a tool of systematic logistics warfare. Mike Reeves's grandchildren watched the documentary together. They saw their grandfather's photograph, heard historians describe his work, and learned about the campaign's operational impact. They laughed at him, one grandson said, referring to the documentary's description of how intelligence officers initially dismissed the bolt idea as too simple to be effective. And then his junk bolt grounded an entire Luftwaffe wing, another replied. That was the essential story. Skepticism overcome by results, simplicity proving more effective than complexity, and one mechanic's understanding of how machines break becoming a weapon that degraded enemy operations for 18 months. The counterfeit bolt operation never achieved the fame of D-Day or the Berlin airlift. It remained a specialized story, known primarily to military historians and logistics specialists. But within those communities, it became legendary, the example of how creative exploitation of technical vulnerabilities could achieve strategic effects disproportionate to the resources invested. In 2024, 80 years after Mike Reeves first disassembled a captured FW-190, the National Museum of the United States Air Force added a display about the Mechanical Countermeasures Group to their logistics warfare exhibit. The display included one of Reeves's original counterfeit bolts, preserved in a sealed case, with text explaining how it had been designed to look legitimate but fail under stress. Visitors could see the bolt, read about its impact, and understand that warfare wasn't just about bombs and bullets. It was also about exploiting trust, degrading reliability, and weaponizing the mundane components that made complex systems function. Mike Reeves had understood that in 1944, he turned scrap metal into weapons and junk bolts into tools of systematic disruption. He'd done it quietly, without seeking recognition, because the work mattered more than the credit. And 80 years later, his innovation was finally recognized not as a footnote in classified files, but as a legitimate example of how creative problem-solving, mechanical expertise, and willingness to think unconventionally could change how wars were fought. The junk bolt had grounded aircraft. The story of that bolt had finally grounded itself in historical memory where it belonged. They'd laughed at the mechanic's junk. Then they'd watched it ground an entire wing. And decades later, they'd learned to respect how effective simplicity could be when applied with precision and purpose.